Very good morning to you all. So yesterday we have gone through the definition of time constant, how the time constant is intended to change the response, okay, through current. Okay, now for the same, for the driven circuitry, the next one that we are going to continue for now, it is derivation of a is a derivation of derivation of voltage across resistor. Okay, so we have already drawn the circuitry. What was our circuitry? Okay, so circuitry we had, it is so let us redraw the circuitry so that you people can understand what is exact the derivation of the voltage across the resistor. So the current we have already defined it through the current. Okay. These are what the things we have defined. So the voltage across the inductor, this can be given by voltage across the resistor. Okay, so to identify the voltage across the resistor, let us start with it is we have already given the voltage across resistor. It can be given as VR of t is equal to R into I of t. Okay, so if we put this value into the equation number 5, we have already written into the previous section, that is equation number 5 that we had. What is our equation? This is what the equation. For now I'll write the same. It is I of t v by r minus v by r into e raised to minus r by l into t. Okay, so if we put, I'll just call over here this equation as 1. Put this one as 1, this one as 2. Put 1 in 2. We will get it as VR of t is equal to put 2 in 1. Sorry, VR of t is equal to r into v by r minus v by r into e raised to minus r by l into t. Okay, which is equal to what? VR of t is equal to r into 1 by r. If I take it as a common, it will remain as t into e raised to minus. So therefore VR of t is equal to v into 1 minus e raised to minus r by l into t. So this is the equation of voltage across the resistor. Okay. So if this is the voltage across the resistor, so this is the equation of voltage across the resistor for a driven RL circuit. So from this equation, okay, from this equation, at t is equal to 0, VR of t is equal to V. Okay, that means what? 1 minus e raised to 0 is equal to what? 0. And and at t is equal to infinite, what will be the condition? VR of t is equal to V. Okay, so what does it mean? It means as t increases, the voltage across the resistor increases exponentially. Okay, so if we have to draw its graph, it will be like this one. T, and this one is T. So this is what the derivation of a voltage across the resistor. Now the last derivation. Okay, then is there any doubt till here? Should I go for the next point? Derivation of voltage. If we are done with now derivation of inductor. Should I go for the next point? Now my voice is clear. Please let me know.
Sir, your voice is lagging.
Just a minute. Now, am I audible? Hello. माझा आवाज येतोय सर्वांना? Hello.
Yes, sir.
Is it clear now?
No, sir.
Now, please tell me. My voice is clear to you all?
Yes, sir.
I
Yes,
need
sir.
to keep that one into my hand actually. Chalo, ठीक है. I'll manage. Please let me know whenever it's like lagging or unclear to you, my voice. I think I had some issue with the headset today. Chalo, ठीक है. Okay. So next point that we are going to continue with, that is derivation of voltage across inductor. Okay, so the voltage across inductor so this can be written as VL of t is equal to what? L into d by dt of I of t, right? So if the equation we have already gone through, what is the equation that we had? Equation number, initial equation that we have already written. What is in our initial equation? I of t is equal to v by r minus v by r into e raised to minus r by l into t. Okay, let us call this one as 2, this one as 1, and this one as 2. So if we put this value, that put equation number in 2 in 1, so what we will get? We will get it as BL of t is equal to L into d by dt, okay, of v by r minus v by r into e raised to minus r by l into t, which is nothing but L into d by dt of v by r, okay, minus L into d by dt of v by r into e raised to minus r by l into t. Therefore, so the equation 0 minus L into v by r into minus r by l into e raised to minus r by l into t. So therefore, what will be our final equation? If you solve it, PL of t is equal to v into e raised to minus r by l into t. Okay, this is what the equation. Now this is the equation of a voltage across. This is the equation of voltage across inductor for the driven RL circuit. So at, I'll just write, at t is equal to 0, what will happen? VL of t is equal to V, and at t is equal to infinite, VL of t is equal to what? V into e raised to minus infinity. Minus infinity means what? 0. So it means what? The VL of t decreases exponentially because it is reaching towards the 0. So initial value and the voltage across the inductor will decrease. Decrease exponentially as when the driven voltage source will be defined PL of t. This is what the type, and this is the Z. Okay, have you understood? Shall we go for the next point? Shall we go for
Yes,
the
sir.
next point? Yes, thank you. Just a minute. All of you can see my screen?
Yes, sir.
Yes, sir.
So it is effect of initial current. Effect of initial current. So to start with effect of initial current, we have considered that initial current is 0. So as initial current is 0, suppose some of the initial current, that is I0, is present before the switching action. Okay, so before the switching action is, if there is some current, then the initial current or the equation, that is I of t, if we want to modify, that is I of t, we have already written I of t is equal to V by R minus V by R into e raised to minus R by L into t. If this equation we have, if this equation will be modified as with respect to the new current, or if initial current is present, it will be V by R minus I0 e raised to R by L into t. So at time t is equal to 0, I is equal to V by R, okay, minus V by R minus I0 into e raised to 0, which is equal to what? I0. So the current waveform can be defined as what? The current waveform, therefore the current waveform, or a graph we can say, it will be like this one. It will start at some extent. See, I0 is not 0, so it is initial current is present. Okay, and this is what the maximum value we have, is V by R. So which is with respect to the time, so it will increase exponentially. And similarly, if we are knowing that voltage across the inductor, it can be defined as, I'll just write voltage across inductor. So it can be defined as VL of t is equal to V minus I0 into R into e raised to minus R by L into t. So at time t is equal to 0, VL of t is equal to V minus I0 into R. So therefore the variation of V or the VL of t versus, or if we want to identify versus time, this can be identified as or defined as it will decrease exponentially. Keep in mind. Okay, so this is what the time t 0 initial condition that we have, it is v minus I0 into r, which is nothing but VL of t. So this is what the condition which is associated with a driven RL circuit. Is there any doubt? Is there any doubt?
No, sir.
Okay. Guys, the next point that we are going to continue for now, it is the undriven or a source free RL circuit. Okay, undriven or a source free. What is the difference between source free? See, in the undriven RL circuit, the voltage source will be not connected. So to define that one, there are the two conditions we need to define. Which one? When the source is connected and when the source is not connected, which is known as the undriven RL circuitry. Okay, so let us start with undriven or source free RL circuit. It is known as the transient response. Means we are going to study its transient response. Okay, so let us consider one circuitry. I'll just draw a RL circuitry which has a voltage source, but this will be used whenever required. Then it has one connector, or the contactor will call a resistor, then one inductor, because it is the RL series circuitry. Let us define this voltage across the inductor VL of t. Okay, so there are the 2 points A, B. Okay, now to start with, let us start with the derivation of current. Okay, so when to start with, consider that this, what we can say, initially the switch which is being connected to point A for a long time period. So what will happen? Network will attain a steady state condition. So if it is the steady state condition, and at that time this inductor acts as a short circuit, so how will be your circuitry now? Your circuit will be like this is what the voltage source, then a connector or the contactor. This is what you have connected to point A. This is resistor, and this inductor acts as a short circuit. Okay, why it is as a short, acting as a short circuit? As it is the steady state condition, and in the steady state condition we have already defined the inductor acts as a short circuit. So what about this one? The switch is closed for long time. Okay, so at that time what will happen? When the switch is closed for the long time, as the switch is closed for the long time, the inductor will be this circuit will be into the steady state, and as it is the steady state, the inductor acts as a short circuit. let us define the sorry guys. Okay, so let us define the current passing through the network. Okay, initial current, we have defined it as the initial current as, let us call this one as I0, initial current. So if we have to identify this initial current, this can be written as V by R, because voltage is only connected and only one resistor is there. So this is the current at t is greater than or the less than 0, and therefore to identify the initial conditions, let us define I of 0 minus, which is approximately equivalent to I of 0 plus, which is equal to what? I0, which is nothing but V by R. Okay, so at time t is equal to 0, it is the switch is connected. Okay, so connected at position B, switch is at B. So how will be your circuit? Will be like this one. This is what R, A, and the inductor L. Let us call this initial as I of t. So when the switch is connected to position B, now the inductor will be present in the network, and this network will be like this one. Okay, and here the voltage source is not connected to the network. So this condition is called the undriven RL circuit. Undriven RL circuit. So now apply KVL. By applying KVL, what you will get? It will be like minus R into I of t minus L into di of t by dt, which is equal to 0. Therefore, R into I of t is equal to minus L into di of t by dt. Therefore, I of t is equal to what? Minus L by R into di of t by dt. Now, by separating those variables, which are those variables? Now, by separating variables, we can write what we can write? Di of t by dt, which is equal to minus R by L into dt. Taking integration of both sides, I'll just write by taking integration of both sides, we get what we get. Okay, with respect to the corresponding variables exactly. So we'll get it as log of I of t, which is equal to minus R by L into t plus k. So here k is the constant of integration, and therefore to calculate the value of k, okay, to find k, let us define by applying initial conditions. So let us define the initial conditions. At t is equal to 0, I of t is equal to what? I0. Therefore, log of I of 0, which is equal to minus R by L into 0 plus K. Therefore, log of I0 is equal to K. Now, let us define these values as the equation. This is what we'll call this one as equation number 3, this one as 2, and the initial one we have defined it as the first one, that is I of 0 is equal to I0 is equal to V by R. That is what the equation number 1. I'll write that one as well so that you people can understand. Let us call this one as equation 1. Okay. Now, to start with, okay, now by putting 3 and 2, what we get? We get log of I of t is equal to minus R by L into t plus log of I0. Therefore, log of I of t minus log of I0 is equal to minus R by L into t. Therefore, log of I of t divided by I0, which is equal to minus R by L into t. So taking antilog of both sides, taking antilog both sides, okay, we get what we get? I of t divided by I of 0 is equal to what? E raised to minus R by L into t. Therefore, I of t is equal to what? I of t is equal to I0 into e raised to minus R by L into t. This is what the condition, and this is the equation of current at t is greater than 0 for undriven RL network. Therefore, now we are knowing that what I0 equal to what? V by R. Therefore, your equation will be now I of t is equal to V by R into e raised to minus R by L into t. This is what the final equation, and this equation, let us call this one as equation number 4, this one as equation number 5. So this equation contains the exponential term, and the power of exponential term is negative, that is this minus R by L. Thus the current through the inductor decays exponentially. Current through the inductor also decays the exponentially. Keep in mind. Hope you have understood this point.